The empirical rule applies only to datasets with bell-shaped distributions, but Chebyshev's theorem that we're using in this video applies to any dataset. But this theorem's results are only an approximate. It is not an exact amount. So what does Chebyshev's theorem say? It says that the proportion of any set of data lying within k standard deviations of the mean is always at least 1 minus 1 over k squared, where k is any positive number greater than 1. So here are some facts about this theorem. We can say that at least 75% or 3/4 of all values lie within k equals 2 standard deviations of the mean. So if you're within 2 standard deviations of the mean, Chebyshev's theorem says at least 75% of all values lie there. Now, at least 89% or 8/9 of all values lie within k equals 3 standard deviations of the mean, which just means if you're within 3 standard deviations of the mean, it encompasses at least 89% of all values. So let's show an example of how to do Chebyshev's theorem. Heights of women have a bell-shaped distribution with a mean of 161 centimeters and a standard deviation of 7 centimeters. We're going to use Chebyshev's theorem, and we're going to see what do we know about the percentage of women with heights that are within 2 standard deviations, and then what about women within 3 standard deviations. So remember the formula, 1 minus 1 over k squared. So let's do the first one, within 2 standard deviations of the mean. So here, k equals 2. So we're going to do 1 minus 1 over 2 squared, which is going to give us 1 minus 1/4, which again, when you do this, will give you 3/4, which proves what we've already shown right here. So what do we say about the women's heights within 2 standard deviations? That at least 75% lie here. So from what value to what value would 75% encompass? So we're going to take what we know, 161, and we're going to subtract our 7 centimeters, our standard deviation, twice, and then we're going to add it twice to see our lower and upper bounds for this question. So we're going to do 161 plus 2 times 7, which is going to give us 175 centimeters. Then we're going to do 161 minus 2 times 7, and that'll give us 147 centimeters. So 75% of all women's heights are between 147 centimeters all the way up to 175 centimeters. Don't need that. So that's what we could say about within 2 standard deviations using Chebyshev's theorem. Now what about if there's 3 standard deviations? Again, k is 3, so 1 minus 1 over 3 squared. It's going to be 1 minus 1 over 9, which again is 8/9. So again, we've shown that at least 89% of all women are within 3 standard deviations. But let's figure out what the actual measurements are for 3 standard deviations. So like before we did plus or minus 2 times the standard deviation, this time we're going to do plus minus 3. So 161 plus 3 times 7 is going to give us 182 centimeters. And then 161 minus 3 times 7 again is going to be 140 centimeters. So women that are within 3 standard deviations would be at least 140 centimeters all the way up to 182 centimeters if you're within 3 standard deviations.